To go to the moon would cost perhaps $100,000 a pound.
Yeah.
When Michio Kaku, the renowned theoretical physicist and futurist, took the stage to reveal his latest findings about the moon, the world was not prepared for what came next. Known for his ability to bridge complex scientific ideas with the public imagination, Kaku's words sent ripples through both scientific communities and public consciousness. For decades, the moon has been viewed as Earth's quiet gray companion, geologically dormant, atmospherically empty, and largely explored. But what Kaku unveiled shattered this long-standing assumption and opened a doorway into a profound cosmic mystery. Before we start, smash the like and subscribe buttons for more updates. He began by challenging the most basic perceptions humanity has held about the moon's origin and structure. Traditional scientific consensus has long maintained that the moon was formed through a colossal impact event, a theory suggesting that a Mars-sized body collided with Earth billions of years ago, sending debris into orbit that eventually coalesced into the moon. Yet recent data, much of it drawn from seismic readings, lunar missions, and deep penetration scans, painted a picture that did not align with this theory. Kaku presented this contradiction not as a fringe speculation, but as a rigorously supported possibility that demands reconsideration of everything we think we know. Central to his presentation was the discussion of anomalous readings deep beneath the lunar surface. These readings suggest that the moon's internal composition is far more complex than a simple ball of rock. Rather than being uniformly solid, the moon appears to contain large hollow regions or structures of varying densities that don't naturally correspond with how planetary bodies of its size should form. Seismic experiments conducted by previous lunar missions, including controlled impact tests, revealed that the moon reverberates in ways more akin to a metallic object than a rocky one. It literally rings, as though its core is composed of something resonant and engineered. This revelation has puzzled scientists for years, but Kaku brought these anomalies into sharp focus, suggesting they are not glitches or outliers. They are the key to a much deeper understanding of the moon's true nature. Kaku also touched on the composition of lunar materials. Samples collected from past missions contain isotopic ratios that mirror those found on Earth more closely than any other body in the solar system. This peculiarity has always stood at odds with the impact hypothesis, which would presumably leave a very different isotopic signature. Even more mystifying, certain materials found on the moon appear to be older than the Earth itself. Kaku pointed to these findings as indicators that the moon may not have originated from Earth at all. If the moon didn't come from Earth, and if it doesn't behave like a naturally formed satellite, then what is it? This question drove the most electrifying part of Kaku's revelation. The moon might not be a natural satellite in the conventional sense. Without veering into science fiction, he suggested that the moon's properties imply a level of intentional design, or at least an origin story that involves intelligent processes not currently accounted for by modern astrophysics. From its perfectly circular orbit and its tidally locked rotation, always presenting the same face to Earth, to the mathematical precision of its size and distance that allow total solar eclipses to occur, the moon exhibits an array of peculiar traits that seem too coincidental to ignore. These cosmic conveniences do not prove anything on their own, but in the aggregate they force a re-examination of the moon's role in the Earth-Moon system. Kaku delved into how the moon has influenced life on Earth in ways deeper than most realize. Its gravitational pull has regulated Earth's axial tilt and stabilized our climate, fostering the conditions necessary for complex life to evolve. The moon's presence influences tidal cycles, animal behavior, even the patterns of human biology. The idea that this body may be more than a lifeless rock, perhaps even placed or guided into orbit under unknown circumstances, was both thrilling and disquieting. Kaku made it clear. The moon's utility for life on Earth is profound, and the emerging data imply that its existence is not as random as once believed. He then moved to the less explored territory of lunar surface features that defy simple geological explanation. Massive hexagonal craters, perfectly arranged ridgelines, and depressions with inexplicable depths have been documented, yet few have offered adequate models to explain their formation. Kaku referenced satellite imaging and data collected from recent lunar orbiters that show geometric patterns in the lunar maria, dark basaltic plains, that don't resemble any known natural processes. These features hint at subterranean structures, some of which extend miles beneath the surface, and exhibit symmetry that raises eyebrows in the scientific world. Further intriguing is the electromagnetic behavior detected around certain parts of the moon. Instruments have picked up localized magnetic fields that should not exist on a geologically dead world. These fields shift and pulse in ways that can't be explained by any known mineral concentrations. Some of them even react to solar activity in curious ways, as though there were dynamic, perhaps artificial mechanisms responding to the environment. Kaku emphasized that while the moon lacks an overall magnetic field like Earth's, these localized anomalies suggest interior complexities we are just beginning to grasp. The implications of these revelations stretch far beyond lunar science. If the moon is not what we think it is, then every related domain, from planetary science to the origin of life, must adjust accordingly. Kaku proposed that our solar system might be far more complicated than the tidy model we've constructed. If Earth's only satellite is a subject of such profound mystery, then what of the moons of Jupiter, Saturn, or the objects in the Kuiper Belt? Are we merely at the beginning of a broader cosmic puzzle? Perhaps the most provocative portion of Kaku's talk was his reference to previously declassified military and intelligence documents. He explained that during the Cold War era, both the US and Soviet space programs had noticed anomalies on and around the moon, flashes of light, unexplained radio signals, and shadowy structures on the far side that seemed to appear and vanish. These were often dismissed or buried under layers of bureaucracy, but modern digital scanning and archival efforts have brought many of them back to light. Kaku argued that it is no longer tenable for the scientific community to dismiss these incidents as mere observational errors. He stressed that this isn't about alien bases or conspiracy theories, but about a systematic underestimation of the moon's complexity. Our natural satellite, it seems, may be far more than a passive chunk of debris orbiting Earth. Its interaction with electromagnetic forces, its improbable geophysical makeup, and its exact positioning all beg for a deeper, more nuanced investigation, one that doesn't start with an assumption of randomness, but with a question: why does the moon behave as it does? As he continued, Kaku drew parallels to other celestial bodies with unusual features, but he kept returning to the moon as the most immediate and accessible enigma. He pointed out that no other planetary satellite exerts the kind of influence over its host planet that the moon does. The scale of this influence is so vast that if the moon were to disappear, life on Earth would rapidly become unsustainable. This unique bond, in Kaku's view, is another argument against the moon being a product of chance. It's as though Earth and the moon were designed to coexist, not just physically, but biologically and energetically. Kaku then turned to the idea of technological signatures in natural systems. He proposed that just as we search for biosignatures in distant exoplanets, perhaps it's time to develop and refine techniques to detect technosignatures, not just out there, but here in our own backyard. Could certain aspects of the moon be relics or echoes of ancient technologies? Could the resonant frequencies, unexplained structures, and unusual densities represent the remnants of an ancient process, one designed with intention? This line of thought led to the consideration of cosmic archaeology, the study of ancient, possibly non-human interventions in planetary systems. Kaku made it clear that while the idea might sound far-fetched to some, science is not served by ignoring anomalies simply because they don't fit our existing models. He called for a new wave of lunar exploration with open minds and advanced technologies: gravimetric mapping, neutrino scanning, deep bore drilling, and long-duration seismic monitoring. These missions would seek not only to gather data, but to resolve the fundamental question now hovering above every space agency and scientific institution: what is the moon really? In discussing these plans, Kaku painted a vivid picture of the moon as a gateway, not just a stepping stone to Mars or a base for deep space missions, but a literal gateway to understanding the larger fabric of our universe. If the moon does not conform to natural expectations, then it may serve as evidence that intelligent processes have shaped parts of the solar system in ways we have yet to comprehend. The potential ramifications are staggering. It would force a rewriting of cosmology, planetary science, even philosophical and existential beliefs about humanity's place in the cosmos. He warned that dismissing these ideas out of discomfort or skepticism is itself unscientific. The purpose of science is not to confirm what we already believe, but to question, to explore, and to adjust when reality defies our expectations. The moon, long taken for granted, is now at the center of a potential scientific revolution. Michio Kaku's revelations invite not only inquiry but courage. The courage to rethink one of the most familiar objects in the night sky. The implications, though enormous, need not be frightening. If anything, Kaku's message was one of inspiration and curiosity. The moon may be more than a silent observer of Earth's history. It may be a messenger, a monument, or even a mechanism. And if this is true, then unlocking its secrets could lead to a quantum leap in understanding not just lunar science, but the deeper architecture of the cosmos itself. So when Kaku concluded his revelation, the room didn't erupt in disbelief. Instead, there was a stunned silence, the kind that precedes paradigm shifts. The moon, once merely a glowing disk in the sky, now seemed like a cryptic chapter in a much larger story. And the message was clear. We have barely scratched the surface, literally and figuratively, of what the moon truly is. The questions it raises are as vast as space itself. And finally, after centuries of assuming we knew it all, we are ready to ask them. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the moon not being what we think? What happens? We want to hear from you. Thank you for watching and see you next time.